Good morning, everyone. So after learning some of those new derivative rules yesterday, we're going to continue on with what's called the product rule. So just first, to get an idea where we're heading here, okay, we're going to recall from yesterday, okay, we had rules for sum and difference. Right? So for example, the sum rule said that if I want to do the derivative of a sum, then I can just do the sum of the derivatives of the different pieces. Okay, so for product rule, okay, we remember from the limit laws, right, that the limit of a product is the product of the limits. So maybe it works the same way with derivatives. Okay, so maybe the product rule maybe is this, right? If I have the derivative of f times d of x, maybe that just means we do the derivative of the first and the derivative of the second function. So let's test this out and see if that's actually what happens. So we're going to write up a simple product here. So let's find the derivative of x squared times x cubed. Okay. So if I go with my idea, okay, that would mean that I would want to do the derivative of x squared times the derivative of, x cubed. Okay, so from our rules yesterday, the derivative of x squared would just be 2x. Okay, and the derivative of x cubed would be 3x squared. And if I multiply those together, I get 6x cubed. Okay, so straightforward enough. So let's verify this. On the side here, okay, I can do that multiplication first. So x squared times x cubed is x to the power of 5. But using the same rule, that means that derivative should be 5x to the power of 4. Okay, so clearly this idea doesn't look like it works. Okay, that is not the right thing. Okay, so this is not the product rule. Okay, so unlike limits, where you can just multiply the limits, okay, it doesn't work that way with derivatives. Okay? So what we're going to do now is give you the actual rule and then do a couple examples of how it works. Tomorrow's lesson will be going into proofs of why that works the way it does. Okay. So here's the product rule. So if h of x equals f times g of x, okay, and both of the functions are differentiable, right? It's okay to take derivatives. Okay, then I can compute h of x, h prime of x, okay, by doing f prime of x times g of x plus f of x times g prime of x. Okay, or the derivative product of two functions is the derivative of the first times the second plus the derivative of the second times the first. Okay, so you only differentiate one at a time and multiplying it by the other one without taking its derivative. So let's go back to that first example and try again and verify that this works. Okay, so we're going to use the product rule. So to do the derivative of x squared times x cubed, okay, I'm going to start with x squared. Okay, what's the derivative of x squared? It's 2 to the x. Okay, and I leave the second one alone, x cubed. Okay, plus, okay, I leave the first alone, x squared, and I multiply it by the derivative of the second, which is 3x squared. Now we simplify. So I've got 2x times x cubed is 2x to the power 4, and x squared times 3x squared is 3x to the 4. Okay, and when I add my like terms there, I do get 5x to the 4, okay, which is what I expect that I should get, so the rule works. Okay. So we're only going to go over one more example, the same thing. We'll give you lots of time to practice and get used to using these rules, okay, so they become automatic. Okay, so we're going to take the derivative of 4x minus 3 times x squared plus 2x plus 4. Okay, so using the rule, let's take the derivative. I start with the first part, so what's the derivative of the first? Okay, derivative of that is just the number 4, okay, times the second, okay, so leave the second part alone. Plus, okay, this time I'm going to leave the first part alone, 4x minus 3, and do the derivative of the second part. So let's see, derivative of x squared is 2x, derivative of 2x is just 2, and the 4 is gone. Okay, and now we just have to expand and simplify. So I've got x squared plus 8x plus 16 plus, let's get here, 8x squared plus 8x minus 6x minus 6. Okay, and if I collect my like terms, I've got 4x squared and 8x squared, 12x squared, 8 plus 8 is 16 minus 6, and 16 minus 6. Okay, so my derivative is 12x squared plus 10x plus 10. Just as a little aside here, to kind of help me to see that I'm going in the right direction, if I just look at my first two parts, if I were to expand this out, okay, 4x times x squared, right, that would be 4x cubed, and it's my only term that's going to have a power 3 in it. So if I did, what's the derivative of 4x cubed? It is 12x squared, and that's the first thing that I got here. So again, I'm on the right track. Okay, so that's all we're doing this morning. Okay, just taking all those rules that we did before and just combining it with this now. Okay. So the practice work, I want you to work on, and you most likely have lots of time to do this. Okay, so there's no excuses if you don't have this down pat for later. Okay, so it starts on page 93. There's the questions I would like you to have a look at. Have a wonderful rest of the day, and we'll come back with a lesson on proofs for tomorrow.